Okay. So the first thing is, in order to understand polynomials, you got to understand a monomial, because a polynomial is just a lot of monomials put together. So the first thing we have, some examples and we have non-examples. So the examples, we have a number. So any number is considered a monomial. It can be positive or negative. It can be represented as a fraction. It can be represented as a decimal. It is still considered a monomial. We have any variable. So any letter, X, Y, A, B, C. We have the product of variables. So anything with a positive exponent. So notice over here, a non-example is a negative exponent. If it has a negative exponent, it is not a monomial. And then we have the product of numbers and variables. So the combination of all of these put together is considered a monomial. As long as there's no adding and subtracting, that's a monomial. If there's adding and subtracting to one monomial to another or more, that would be here, the sum. That's what's called a polynomial, because monomial just means one. And then once we start adding or subtracting more than one monomial, we consider those to be polynomials. So here we have a polynomial. When looking at fractions, if the denominator is unknown, like it is here, that is a non-example, or that is not a monomial, and it is not a polynomial. So also exponents, if they are a variable. So if the exponent's a variable or a negative, it is not a polynomial and it is not a monomial. So our basic definition for a polynomial is that a polynomial is a sum or the difference of different monomials. So basically, those monomials that we see back here, if we are adding or subtracting them, then that's what's considered a polynomial. At that point, you have more than one, and it's considered a polynomial. But if you have more than one and they don't fit this criteria here, then it is not a polynomial. All right, so on to today's major lesson, which is standard form, degree of a polynomial, and leading coefficient. So I have these two examples here, and right now they are not in standard form, okay? This is not standard form, this is not standard form. So the definition of standard form is when you have, you're gonna list your variables in order from greatest to least. Probably should talk about that, right? So standard form is when you list the terms in a polynomial by its exponents from greatest to least. Okay, so we're going to order the exponents and we're going to move the terms around so that the greatest exponent comes first. That term that has the greatest exponent comes first, and then it continues to descend or go down after that. So this first one, we have, we're looking at the exponents here. We have a 3 for this exponent. We have a 2 for this exponent, and we have a 1 for this exponent. So what we're going to do is we're going to reorder these. We're going to start with that term. And this one right here, it doesn't have a variable, so we consider this exponent to be 0. So I'm going to start with the 4x is positive. So 4x to the third is going to come first because that's the greatest exponent in this polynomial. Next, I'm going to move down to 2. So that's the 3x squared term. And then down to 1, taking the sign in front. So negative 9x. I don't have to write the 1. And then the last thing with no variable in 0 degree would be the negative 7. So this is the standard form for the first one. And then here I have 4. This is going to be my first term. And then there's no 3. That's fine. Go down to the next number. Here's the exponent here is 2. Exponent here is 1. Exponent here is 0. So I'm going to put this in order, starting with the 4. Degree 4, so I'm going to do 5x to the 4th. There's no 3, so I'm going to move to minus 2x squared, and then positive 8x, and then minus 3. All right, so the next thing we do is we move on to the degree of the polynomial. So the degree of the polynomial is, oh, I can't switch. I'm going to type the definition in here. So degree of a polynomial is simply the greatest, it's the greatest, or it's the value of the greatest exponent. That's on the monomial. So in order to find the degree of a polynomial, we're looking for the greatest exponent, and whatever that value is, that's the degree of our exponent. So looking at our examples, the greatest exponent, since we put it in standard form, is just going to be the exponent. The term that comes first is going to be that exponent because we put them in order. But you can still see what the degree is if it's not in order just by looking for the greatest exponent. So this first degree is 3, and the other degree is 4, greatest exponent. And then last, we want to talk about the leading coefficient. The leading coefficient is the number that is in front, once it's in standard form, is the leader of all of the entire expression. So what is that very first coefficient that you see? That's the leader. So what's leading off on this red polynomial is 4. That's the first coefficient there. In technical terms, the leading coefficient is the coefficient of the greatest exponent. So you don't have to have it in order again, but you do have to go look for that greatest exponent, 3, and then take the coefficient of that term and the sign. So be careful with the sign. If the sign is negative in front of there, then it is a negative term. And then this last one, the leading coefficient is 5. It's easy to tell when it's in standard form. When it's not in standard form, you have to go and look for the greatest exponent and then take the leading coefficient, or take the coefficient of the greatest exponent. So this one is 5.